tetrachloride. It has 4 surrounding atoms, so that makes it a tetrahedral. And the bond angles are 109.5 degrees.
A metallic bond is a chemical bond in which electrons are shared over many nuclei and electronic
Ionic
conditions.
compounds are composed of both a metal and a nonmetal. They involve the transfer of electrons and they have a big electronegativity difference. They have high melting and boiling points, and they're generally hard crystalline structures. The smallest unit is called a formula unit, and it forms lattice structures. They do not have frequency.
Covalent bonds are composed of two nonmetals and they're not polyatomic. They involve sharing electrons, and the atoms have small electronegativity differences. They have low melting and boiling points. They are soft solids or gases or liquids. The smallest unit is called a molecule, and they include frequency.
Polarity is defined as having two opposite tendencies or opposite electrical charges. The molecule that we chose was CCl4, which just happens to be nonpolar because it is symmetrical, which means that all of the outside electrons are identical.
VSEPR stands for valence shell electron pair repulsion. The theory states that electron pairs will orient themselves as far away as possible to minimize repulsion. The polyatomic ion we chose to use was nitrite. The way that we determine its structure is by calculating the number of valence electrons in the formula. The formula is NO2 minus 1. N has 5 valence electrons. O has 6 valence electrons, but there are 2 oxygen molecules in the formula, making it 12 total. When we add the 12 and 5 together, we get 17, but we can't just leave that negative 1 there. We add it, and it becomes 18 valence electrons in the formula. Second, we start to draw our Lewis structure. We start by putting the element we have the least of in the middle, which happens to be nitrogen in this case. So we start with N. Then we connect the other elements with single bonds. So since there are 2 oxygen molecules, we just attach those with single bonds. Then we add dots around the elements to signify valence electrons. Then we count up the valence electrons in the structure. There's only 16 valence electrons in the model, but we're allowed to have 18 valence electrons. So we add 2 to the middle atom, which is also known as the central atom. Now we have 18 valence electrons, but not all of our atoms are stable. The central atom is unstable. It only needs 2 more. So what we can do is share with the central atom from the outside atoms. And we just take off 2 from here and add it here. So our final Lewis structure will look like this. Now this structure may look linear, but it is not linear. because there's a lone pair on top, that pushes the other molecules down and decreases its, what is that called? Decreases its bond angles. So the structure of this atom is trigonal pyramidal because it makes a pyramid, and it is triangular because it has 3 sides.
Okay, the molecule we'll be doing is CCl4, which is carbon tetrachloride. Okay, so the first step is to figure out how many valence electrons it has. So carbon has 4 and chlorine has 7. But there's 4 molecules of chlorine, so we have to multiply 7 by 4, which is 28, and add 4 from carbon, which would give us 32 total valence electrons. Now for the Lewis structure, you put carbon in the middle because it has the least valence electrons, and you put chlorine around it. Since they want to be stable, you put 6 dots around here, and the line counts as 2 electrons. Now this forms a tetrahedral, and it's non-polar because all the outside elements are equal or the same.